Welcome to Chakwa International. I'm Nilamata Jana speaking. This is Gate Electrical Slot 6 on control and measurement. The first problem is to know the Mason gain formula, including sometimes also know the Mason gain formula for multiple input, because Mason for single input very easy. You will make one or two calculations multiple input so that you can attempt any type of questions. This is the steady state error analysis, and if you know the steady state error analysis, you can do this type of problem. Very easy one. ESS is equal to limit S to the 0 SES. Then another thing you should know the Laplace transform. You should know the Laplace transform. Here also you should know what is the character equation is 1 plus GSHS. What is the formula of unit feedback? So S square to omega ns into omega double n square. Here you can know the sigma and you can know the double n. Now you can know the epsilon, you can know the double n. So accordingly you can check the maximum overshoot. Second formula also same. Is not what is the transform functions calculations. Then the steady state final value, that is y to the infinite limit s to the 0. Then the formula k what is coming like the kGSHS. Here the root Horridge equation, in the first column 2 sign change, that means 2 sign change means two pole present in the right hand side. Right hand means unstable. With the border plot actually the graph of the transfer function of a linear time invariant system frequency plotter with log frequency axis to show the system frequency response. The variation like the constant gain k, poles at the origin, first order factor, quadratic factor. Accordingly it varies. You can know. Another thing, here the first questions one line is missing, that is a unit feedback system has an open loop transfer function GS. The first line is missing, that is asymptotic approximation of log magnitude versus frequency plot of minimum phase system with real poles and zeros is transfer function like this. The same thing, the same border plot is continued. The maximum phase transfer is 632 rad per second. This it is for state variable system. Roots are right as S plane. The system is unstable, and the controllability AB is controllable is there. AM is equal to 0, so not controllable. Then lead compensator is there. Lead compensator formula is there. Alpha t is equal to 0.4. Alpha is equal to 10. So t is equal to T is equal to 0.4. The maximum phase angle will be 55 degree. The formula based problem. Here for the system. This is the problem I just completed. This one is the state variable system. System is not controllable. Another one is the system with the steady state with the maximum phase angle, the sine inverse alpha minus 1, alpha plus 1. Alpha t 0.4, alpha t is equal to 0.4, so alpha is equal to 10. Accordingly, you can do it. GSHS k s plus 2 bracket we have not the root or locus problem bracket problem is equal to root over dk by ss. It is come minus 2.5 and minus 744.5. This is important for easy problem also. The resistance R on the measurement problem, you know, this is a very easy one. You have to call the parallel combination 10.5, very self-explanatory. Next also self-explanatory, tolerance AM by 80 divided by 80. The PMC permanent magnitude RS is equal to RB 2RD minus RM. A moving iron armature is TD is equal to half I square di by d theta. Here, the 105 frequency has a bar frequency primary is the transfer ratio of primary winding control to secondary winding control. The ratio is nominal transfer ratio the transformation ratio. On the energy meter, the reading is that the energy reading 5 is equal to tan minus root of T omega minus omega 2. Here omega is 1 is 10.5, another is minus 2.5. So total power is equal to 8 kilowatt. AC bridge is equal to the opposite end impedance multiplication opposite end AC bridge. AC bridge opposite end impedance. So Z1 is equal to the 5. The example 5 and ohm into ZL is equal to 300 plus JL into 300 plus JXC 1 by JXC. That is it is a value of the standard bridge system. This is a Lissajous pattern. On the first one case, here the frequency is T, but here the second frequency 2T. So frequency maximum control signal is 1 by 2T, F sweep by 2. So F sweep by 2 is the frequency. Here is the Lissajous pattern. Here Nx is the number of horizontal peak, Ny is the number of vertical peak. Accordingly, you can do it. Fi by Fx is Nx by Ny. Here is a Q meter. Q meter formula is 1 by WCR 120, but it is one capacitor added, so C2 changed to 200. The first case C is coming 300, and the first C100, then after that C2 is equal to 200, so Cx is coming 100. With this, the present complete. Like it, put the bell icon, subscribe. Thank you.